Welcome to our comprehensive tutorial on adding multiplayer functionality to your Java game. Whether you're looking to enhance player engagement or just want to challenge your friends, adding multiplayer features can make your game significantly more exciting. Before we dive in, let's briefly outline what we'll cover in this tutorial. We'll start by discussing the fundamentals of multiplayer game architecture, then we'll cover the client-server model, and finally, we'll implement a simple multiplayer setup using sockets. So, grab your favorite code editor and let's get started. First, let's talk about the basics. Multiplayer games usually involve a network architecture that allows multiple players to interact with each other in real time. The most common architecture is the client-server model. In this model, the server handles game logic, player communication, and data management, while clients interact with the server and each other through it. Here's a basic diagram to visualize this setup. The server acts as a central hub where all communication flows through. Clients send actions to the server, which then processes these actions and updates all clients accordingly. Now let's create a simple Java server that can handle multiple clients. This server will be responsible for accepting connections, handling player input, and broadcasting game state updates. To do this, we'll utilize Java's sockets library. In this code, we initialize a server socket on port 12345 and enter an infinite loop, waiting for client connections. When a new client connects, we create a new client handler thread to manage that client. Now, let's implement the client handler. In the client handler class, we maintain an output stream for each client and allow them to send messages to all connected clients. The broadcast message method sends messages to all connected clients. Now that we have a basic server, let's implement a simple client that can connect to this server. In our client code, we establish a connection to the server and set up streams for input and output. We also start a separate thread to continuously read messages from the server, allowing players to send input while also seeing real-time updates. It's time to test our server and client. First, run the game server. You should see the output confirming that the server has started. Next, run multiple instances of the game client. You'll notice that each client can send messages to the server, which in turn broadcasts those messages to all connected clients. Let's test this functionality now. Type a message in one client window and see how it appears in others. Now that we have our basic multiplayer framework set up, let's discuss enhancements. Right now, players can only send text messages. To make this more fun, we could evolve this to support player actions, item interactions, or perhaps even a simple game loop. An example would be adding player coordinates to manage their positions on a game board. Let's modify our client and server logic to handle player positions. Each client will send its current position to the server, and the server will update other clients. We'll need to adjust our message format to include the player's ID and its corresponding coordinates. In the position message class, we will hold the player's ID and coordinates. Now our broadcast message method needs to know how to handle these position updates. Let's update the logic in the server to recognize this new message type. Now we can differentiate between normal messages and position updates. Next, we need to send position updates from our clients. Let's modify the client code to capture user input for movement and send these updates. With this change, we can now send movement commands like move 10:15 from your client. This updates the server and broadcasts the new position to all clients. Now, let's test again to see if players can move around the game world. Make sure all clients are running and update their positions accordingly. Fantastic! Now you have a basic implementation of multiplayer functionality. You've learned about socket programming, client-server communication, and even how to extend your game's functionality to handle player actions. As always, there are plenty of paths to take from here. You could work on robustness, adding techniques such as client-side prediction and interpolation, or you could consider security by validating player actions. Think about features such as persistent player data or implementing game matchmaking, which can add even more richness to your game. Remember, building a game is an iterative process. Keep refining your game mechanics and features based on user feedback and testing. Join us next time for more advanced topics like persistent storage, user authentication, or applying design patterns that will make your architecture cleaner and more efficient. If you enjoyed this tutorial, don't forget to like, subscribe, and leave a comment below with what features you're looking forward to adding to your game. Happy coding!